Okay, so this is part 3 of our study on permutations, and that's going to be the last part on this, and then we're going to look at combinations. So we looked at permutation, next one will be combinations. So remember, in permutations, the order matters. Remember that? Okay, that's important. Now, in part 2, we saw a formula for uh, permutations. So if I have something like permutations of n objects taken r at a time, we know the formula says n factorial divided by n minus r factorial, just like that. So, for example, and again, this part's a review from part 2. So, if if I want to find the number of permutations of 7 objects taken 3 at a time. So, remember, using our calculator, make sure you know how to use your calculator. So, you remember how to do that. You're going to say 7. You're going to say 7. I'm going to go ahead and move it over. So it'll be 7. What do I press next? You press 7 first. What do I press next? You go to probability. And then you see it's already underlined our permutation formula. So press equal. Then you say 3. And then equal. And there's your answer. It's 210. Now, that's using calculator. Remember, though, when we did part 2, we looked at this also in terms of uh, actually what it means, actually writing it out. So remember, this means 7 factorial, using our formula, divided by, and remember r here is 3, so divided by 7 minus 3 factorial. So that's 7 factorial divided by, and that's 4 factorial. So that becomes 7 times 6 times 5 times 4 factorial. Remember, we stopped there because we have 4 factorial in the denominator. Those divide out, and you're left with 7 times 6 times 5, which gives us 210. Okay? All right. Now, what we're going to do next is apply this formula with some word problems. And the ones we're going to look at are fairly simple. The ones in your book as well in my math lab. All right, so let's go to the first one. So you have this in Canvas, so make sure you get that out. I'm going to go ahead and enlarge this. Let's see. Okay. All right, so you're told in number 1 that a club has 4 officials. President, let me go ahead and see if I can, this is the best I can do. All right, so president, vice president, secretary, and treasurer. Okay? And there are, and each member cannot hold more than one office. And there are 12 members in this club. So the question is, in how many ways can the officials be elected if the club has 12 members? All right? So again, order does matter here because you have president, vice president, secretary, and treasurer. Okay, so basically, if you think about it, there are 12 members for the president. There are then there become 11 members for the vice president, and so on, right? Okay, so the order does matter. So, but let's use a formula. I want you to use a formula. So the formula for this then would be P. This is what you would write. So you'd say P. All right. So how many members do I have? 12, and I'm choosing how many? 4. Okay. So number. So you're asking basically the number of permutations of 12 members taken 4 at a time. Now using your calculator, that's going to equal. Let's see. So we press 12 first, right? 12. Then probability equal. And then what was it, 4? And you have that many possibilities. So 11,880. Okay. All right. So what about this one? So that would be number of permutations of 16 members taken 4 at a time. So again, using your calculator, that's what we get. So 16 probability equal 4 equal 43,680. Okay? All right. Number 2. You have been asked to judge an art contest with 15 entries. In how many ways can you assign first, second, and third place? All right, so again, I want you to use permutation. It's the permutation formula. So use in use the permutation formula. Okay, all right. So here you're going to say P. So what's the total number of entries I have? 15. And I'm ordering them in how many ways? 3. Actually, I should have said there are how many objects. So I have 15 objects to choose from, and I'm picking how many? 3. Okay, so that'll be 3 here, and because that's first, second, third place. And so in your calculator, you're going to say 15 probability equal, and then 3 equal 2,730 ways to pick first, second, third place. Okay. Number 3, 10 students are chosen from a class of 22 and lined up for a photograph. How many such photographs can be taken? All right, so they're lining them up. So the order does matter. Okay, the order does matter. All right, so you're going to say probability, permutations. You have 22 altogether, and you're choosing how many from those 22? 10. And so let's see how many possibilities there are. So you say 22, PRB, 10, equal. Oh, good Lord. Okay. So maybe I should have made this much smaller because I get this. So let's make this, let's say 7. All right, so let's put 7 here. So let's see what happens. So 22, probability, I keep saying probability, permutation, 7 equal. All right, so that's a little bit better. I can see all the digits. I changed that to 7 because I couldn't see all of my digits. It was written in scientific notation. So 8, 5, 9, 5, 1, 4, 1, 7, 6, 0. Good Lord, that's a lot, isn't it? So 859, a little over 859 million. Okay? All right, now, before we look at 4, I want to discuss something here. So let's look at 4 for a moment. So it says this, find the number of unique permutations of the letters in each word. So they use the word unique. We're going to talk about that in a little while. But if you look at the letters that are in the word design, DESIGN, okay? And the question is, in how many ways can you form, can you arrange the letters that are in this word? All right, so how many letters do you see? You see 1, 2, 3, 4, 5, 6, right? 6 distinct letters. All right, so let me go ahead and put right here, use permutation formula, and when I'm talking about, I mean this for 1 through 3. All right, 1 through 3. All right, now, do y'all agree that this right here would be 4, I'm sorry, how many choices with the first for the so you're arranging the letters, right? So there's 6 of them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you have 6 choices. You've already chosen one. Then how many left? How many you have left? 5, 4, 3, 2, 1. Right. So that's going to be equal to 6 times 5 times 4 times 3 times 2. So that's 720. But I want you to notice something else as well. Okay, I could have used this formula with that. So watch. So the number of permutations of how many letters do you have? 6 taken what? 6 at a time. Y'all agree? Isn't that what that says? Okay. So that's going to be 6 factorial over 6 minus 6 factorial. So that's 6 factorial over 0 factorial. So that's 6 factorial over 1, which is 6 factorial, which is what this was. This is 6 factorial. Y'all agree? Okay. All right. So I could have used this in here. Let's do the same thing. Let's actually use this for letter B. Because notice you have MATH. How many? Those are all distinct letters, correct? Those are all distinct letters. So I can say that'll be the number of permutations of 4 letters taken 4 at a time. You're putting all those letters, using all those letters. You want to see how many 4 word letters you can use, how many 6-word letters you can make up. Okay, so that would be, and you could use your calculator on that. So it'll be 4 PRB equal 4 equal 24. Okay. All right. Now notice though the difference between A and B and C is this. In A, were any of the letters alike? No, they were not alike. B, were any of the letters alike? No, they were not alike. So I could have gone directly to my permutation formula. But in C, I have 3 of my letters are alike. 3 of my letters are alike. So let's talk about that. All right, listen carefully to this. So this words has letters that duplicate, right? These letters I'm sorry, this word has letters that duplicate. You have duplicate letters. All right, so let's talk about that. Okay, so this is going to be permutations. Our discussion here is going to be permutations of duplicate items. All right, so we're going to start off with a simple example. So let's look at the um, the number permutations for the letters in the word set. Okay, so if I look at the word set, those letters are all distinct, correct? Those letters are all distinct. So so um, since they're all distinct, using the counting principle, fundamental counting principle, I can say, well, there are 3 choices for the first letter, then there are 2 choices for the second, and then 1 choice. So that's 6. Y'all agree? Which is really 3 factorial. All right, y'all agree with that? Okay, we can actually find them. SET, then I can say EST, then I can say TES, then I can say TSE, then another would be ETS and STE. And I think I got all of them. 1, 2, 3, 4, 5, 6. All right, so those are the 6. Okay, so these are the these are the permutations of the letters in the word set. Okay. All right. Now, um, okay. What if I had this? What if I had find the number of permutations of the letters in the word Anna? Okay, in the word Anna. All right, now notice this time 2 of the letters repeat. Okay, so listen carefully. I am going to go ahead and use a different color here. So I'm going to use blue for the first A, okay, and then N, and then red for the second A. All right, okay, so blue and red. All right, so I'm going to go ahead. Using these colors. I'm going to go ahead and list uh, all the possibilities using these 3 different colors. All right, so because I had 6, right? So I have 3 letters. You would think you would have 6. Okay. All right. So let's look. So I can have um, A. The first one could be A. N. A. Okay. Then the second could be A. N. A. All right. Just different letters. Okay. Then I could have um, A, A, N. I'm trying to get all of them. Then you could have N, A, and then you could have N, and then just changing those two letters, A, okay? Then I can have, all right, I have those. I'm missing one more. Let's see. So I have A and A, A and A. Then I have AAN. If I, so be, oh, okay, yeah. So, okay, so then I'm missing this one that goes with this one. So it'll be A, N. All right, so those are my 6. Okay? Now here's what I want you to notice. Do y'all agree right here that even though my colors are different, it's the same word, right? A and A. That's the same word. Okay? If I look at this one right here, even though my colors are different, AAN, red A, blue A, N, blue A, red A, N. Do y'all agree that's the same set of letters? Okay, so that's another one. Do y'all agree that those are the same? NAA, NAA. So really, for that word, for this word right here, where I had the letter A repeat, how many permutations did I end up with? I ended up with 1, 2, 3. So there are 3. So answer, 3 permutations. So that's going to take us to a formula, and here's our formula. All right, so that's going to be a new one. So permutations, this will be permutations of duplicate items. Permutations of duplicate items. So it says this, the number of permutations of n items where p items are identical, q items are identical, and so on, r items are identical, and so on, okay, is given by, and here's the formula. So it'll be n factorial divided by p factorial, q factorial, r factorial, and so on. Okay? All right, so let's go back to our example. So based on our example, okay, using the example A and A, so if I want to find the permutations, number of permutations, I know it's 3. Okay, we know the number of permutations is 3. So the number of permutations using this formula now is, all right, so 3 factorial. All right, so how many, so if I look at the letter A, how many do you see? 2. So you can say divided by 2 factorial. So that's 3 factorial. Well, it'll be 3 times 2 factorial divided by 2 factorial. The 2 factorials divide out and you're left with 3. 3 times 1 is 3. All right, so we had, that's what we got right here. All right, so 1, 2, 3. Okay, so let's look at some other examples. So let's look at, let me see if I can find our sheet. All right, so let's go back to C now. So go back to C. All right, so you're going to say this. You're going to say 1. So how many letters are there? There's 1, 2, 3, 4, 5, 6, right? So it'll be 6 factorial divided by, see some letters repeat. Letters repeat. So how many letters repeat? The letter E repeat. How many are there? 3. So divide by 3 factorial, and just use your calculator. So 6 factorial, divided by 3 factorial. Press equal, and you get 120. All right. So I could have used in A and B. I could have used that as well, but there's nothing to repeat. So down here, you wouldn't have anything. It would just have 1 factorial, which is 1. So in other words, see where I had letter A right here? Okay, so basically in letter A, you would have said 6 factorial divided by, and then all these, none of them repeat, right? None of them repeat. So you would just say 1, so that's just 6 factorial. Okay? Because the repetitions go in the denominator. There are no repetitions, just put the number 1, and you get that. Okay, so let's look at further. So are there anything that repeats in further? Yep. The R's repeat. How many are there? 2. So 1, 2, 3, 4, 5, 6, 7. So that'll be 7 factorial divided by 2 factorial. And so that's going to equal, so 7 factorial. Make sure you know how to use your calculator. Divided by 2 factorial. And then you get 2,520. All right, let's look at ballistics. All right, so, okay, now this time you have more than one letter that repeats. Okay, but let's count how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial. Okay, the repetitions go in the denominator. So B does not repeat, A does not repeat, L does. So that's 2 factorial. I repeats, so that's another 2 factorial. S repeats, so that's another 2 factorial. T does not repeat, I already took care of, C does not repeat, S already taken care of. Okay, so that's what you get here. All right, now when you calculate, you're going to say this. You're going to say 10 factorial, divided by, and then what I would do is I would put this in parentheses like this, put that in parentheses, so divided by parentheses, and just say 2 factorial 2. I'm not sure if you, let me go ahead and just do it like this to see if I can get an error, because I'm thinking I may need to say times another 2 factorial, but I think we're okay at this point. And then times another 2 factorial. Oops, messed up. Ah, doggone it. All right, let's do this over. Oops, I messed. Okay, let's do it again. So 10 factorial divided by parentheses 2 factorial. Now that you really don't have to go through all this to find 2 factorial, because what's 2 factorial? 2 factorial is 2, right? Y'all agree? So you really don't have to. You could have just said, well, that's 10 factorial divided by 8, because 2 factorial is 2, so 2 times 2 times 2 is 8, right? All right, but I'm just trying to see if I can get this into calculator, make sure it works. So probability, permutations. Okay. All right, then 2 factorial again, then 2 factorial again, close the parentheses, press equal. Okay. All right, so that's going to be this amount. So 453,600, which is what hopefully 10 factorial divided by 8 is. So 10 factorial divided by 8, yeah, gives the same thing. Okay? All right, so let's get part F. So in part F, you have the word billionaire. So there are how many letters? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it'll be 11 factorial divided by, all right, so let's look at B. B doesn't repeat. I repeats 3 times. I need 3 factorial down there. 1, 2, 3. Okay. L repeats 2 times, so times 2 factorial. O does not repeat. N does not repeat. A does not repeat. I've already taken care of. R does not repeat. And E does not repeat. Okay? So that's what I have right here. So let's use our calculator. Don't forget to put this in parentheses. All right. Okay. So I have 11 factorial. 11 factorial divided by, okay, parentheses, 3 factorial times 2 factorial. Okay, close the parentheses, press equal. Let's see how it looks. Okay, press equal, and you get this. So 332,640. So 3,326,400. So there are that many ways to arrange the letters in the word billionaire. Okay, all right. Okay. Okay. So maybe I should also say those are the number of unique permutations. All right. So remember, we got to take care of the letters that repeat. All right. So that's now if the letters that let's say you had 11 letters here and none of them repeated, it would be a lot bigger than this, right? So it'll be 11 factorial. So 11 factorial is that amount. Okay, so it's 3,991,000. Oops, sorry. So oops. So it'll be 39 million. See how that looks? So if I had 11 letters and none of them repeated, so if you had 11 letters and none repeated, then that would just be 11 factorial, which is 39,916,800. All right, over here, I had 2 of the letters that repeated. One repeated 3 times, another repeated 2 times. So it decreased this number here to that amount. Okay, so that should take care of the lessons with permutation. So there are 3 parts. You need to look at all 3 parts before you look at any of these, before you do my math lab in particular, and before you do the worksheets. All right, so that's going to take care of permutations.